So everything we've showed you so far is kind of understanding the mental model of branches and how they relate to remote repositories like GitLab. Now, I'll tell you that in practice, when you're working on larger teams, it's actually very rare that you're working on master locally and merging these changes manually and pushing those. Um, because we kind of want to keep master this sacred place that we don't modify in ways that we aren't intending. So instead, a much more common route is to use these things called pull requests or merge requests, the same thing, just different terms for those, on our remote repo website like GitHub or GitLab to help us facilitate this process of sharing, reviewing, and merging code. So I'll show you the steps for how to do this in 1 second. But this doesn't invalidate everything we just did in the last video. It's really important to understand this concept of branches and how those relate to our remote repositories and what these merge conflicts are, because we could still run into them in this pull request world. But now that we kind of have the tools to talk about them, we might understand kind of what's going on in this UI. Now, all of this probably is going to sound like a lot of extra steps. Why would we go through this? But the main goal is in some sense to be extra steps because we want to be very deliberate about what we're putting in master. Remember, master, and particularly the master on GitLab, is kind of like our established version of the project. And we want to make sure we're not accidentally introducing bugs that might have come from me handling a merge conflict or something like that. We really want to be deliberate with what's allowed into master, because what goes in master can have real impact on the world. For example, if you're writing a website for a bank, you accidentally pushed a change that deletes a lot of bank accounts, a lot of people wouldn't be very happy. And even more extreme, there's a lot of increasingly automated parts of our world, like self-driving cars. And if you pushed a change to self-driving cars that caused a bug, that can cost a loss of life, which is a huge deal. And so we really want to be careful about what changes we actually put in master. It turns out that a lot of companies take this so seriously that they actually prevent you from pushing to master directly. They kind of turn it off in GitLab or GitHub. You're not allowed to push to master. The only way to get changes into master is using this thing called pull request or merge requests that I'm going to introduce in 1 second. As a quick reminder, I'm going to kind of leave the state of the repo at where it ended in that last video. So we've kind of already gone through all of this like local merging and stuff. Right now, our most recent commit is this M commit, and my local repo is currently synced with the remote repo. This is going to end up causing some of my diagrams to get a little bit complex because it's going to include all this A, B, C, D stuff. But in some sense, you can ignore, for this part of the video, you can ignore everything before M. M is like kind of the starting point from where we're going to be working on for the most part. But I just wanted to leave in like all of that past history is still there, but it's not going to impact us really for this exercise. So what I'm going to do is kind of use this process that I used in my first video, where I want to work on a new feature. So I'm going to go ahead and make a feature branch. So make a branch in my repo to kind of work on. And then I'm going to show you how you can like take changes from that branch and merge them into master, but going through this more established way on GitLab. So I'm going to go ahead and show you that if I do git log, we're currently on the M commit and everything's synced up with Git, with my master, origin master, everything's good. I'm going to go ahead and I'm going to add a line that says X. I'm going to switch to X and Y for these next commits, just because we've been doing A, B, C, D for a little while. I'm going to stage this. Oh, sorry. I want to undo this. So I'm going to, I don't want to commit this on master because we said we don't really want to work on master. So I'm going to go ahead and undo this. So restore file.txt. Oh, sorry, restore -- staged. This is the command to unstage a file. How did I know that? Git told me this right here. It says, oh, if you want to unstage, do this. And then I'm just gonna kind of leave this as is. I want to make a feature branch. So remember, if we wanted to make a feature branch, we had to do this git branch feature, and then we had to check out that branch. I'm gonna show you that there's actually a shorthand for this. You could do git checkout -b feature. This is a shorthand to say if this branch doesn't exist, please create it. So I just switched branches. Notice it's totally okay. My changes on my working directory actually didn't get messed up because this branch was new. Git is actually pretty smart about that, which is great. So now I have my feature branch. If I do git log, you can see that the feature is the same place as master. We're all good, and my head is currently on feature. So now I'm going to stage this, and then I'm going to commit this, and I'm going to call this commit X because I just added the line X here. If I do git log, you can see my head is at feature, which is on X. The previous commit is where origin master and master are, which is on M. Now, I'm going to quickly switch to, before I kind of show how to merge these changes in master using GitLab, I'm going to do one thing. I'm going to switch to Shadowhunter real quick. And Shadowhunter is going to add a new commit to master on origin using kind of our old approach of just pushing directly to master. So I'm going to edit file.txt. I'm going to add a line Y. I'm going to stage this. And I'm going to commit this Y and push that. So it's going to go ahead and push. It's all fine. If you go on to GitLab, whoops, you didn't see that. If you go on to GitLab, you will see that Shadowhunter just added this commit Y. So I just wanted to show that like we can get in the same thing before where other people might be committing to master, or they might be adding their own pull requests, which I'll show you in a second, or merge requests as GitLab calls them. But master could still progress while you're working on this feature branch, and this is totally fine. So let me turn off Shadowhunter. We're going to go back to a regular hunter, back in the nice dark theme terminal, a little less harsh on the eyes. So now what I'm going to do is I'm going to go ahead and push this. So I'm going to push my branch, and notice I got an error here, but it's importantly not a merge conflict error. It's not the same error I got before where it said, oh, there's a merge conflict with origin. This error is telling me, hey, your GitLab your origin on GitLab doesn't know what this feature branch is. I mentioned in my last video that there's this kind of like linkage between your local branches and the branches on the remote. There's a special way you set it up. Honestly, I don't know the command off the top of my head. I just try to push a branch and it says, hey, you need to do this extra step to link these together. So I'm just going to go ahead and do this. You don't really need to understand what this command is doing, but it's really just kind of saying, hey, I want to make a new branch on the remote that tracks this local branch. I'm just going to type this, push this, and it's actually going to give me a URL here to automatically make one of these merge requests, but I'm not going to use that. I normally use this day to day, but I want to show you could just do this through the GitLab UI. If I go to GitLab now, and if I actually refresh the page, it's going to tell me, hey, look, someone just pushed this feature branch. Do you want to make a merge request? Yeah, I do, GitLab. So I'm going to go ahead and make a merge request here. And there's a merge request is just a UI. Let me make this just a slightly bigger. It just like lets you kind of identify kind of what you want to kind of make the proposal for what you're going to add in master. Right now, by default, it's going to just merge into master, but you can change this around if you want. So I want, I can maybe have different branches here as my source, different branches for my target, but I only have one place I want to go, which is master. Oh, my flux just turned back on, so this is going to look a little bit weird, but don't worry about it. You can make a title. So I'm going to make the title of this pull request add feature X. Oh, this is really weird that my flux turned back on. Maybe I'll turn this off for a little bit of consistency. Disable for an hour. There we go. Oh, back to brightness. Sorry about that. Add feature X. This is a really important feature that adds X to the project. You could just describe what this change is going to do. This is different than a commit message in some sense, because, for example, your pull request can actually, or your merge request on what GitLab calls it, can actually have multiple commits. You could have a series of commits that you're trying to merge, but this is describing to other members of your team, like, this is kind of what I want to add to master. And there's usually have like project tracking stuff and all this things. And you could preview what are the commits that I'm actually changing. And you can even preview the changes. Oh, it's adding this X. So let's submit the merge request. And this is kind of a UI now that kind of has my request that I'm going to add to master. I'm requesting to merge feature into master. It's saying that we actually can't merge right now. You can't see this, but I just got an email saying that my merge request just failed. I'll talk about that in a second. But one of the really nice things that this merge request has is it has like a whole commenting system. So I'm working by myself right now, but another developer could say like, wow, this feature looks great. Please merge once you fix the merge conflict that we just ran into. You can comment on this, you can react with emojis. Teams usually have some kind of like fun conventions for like what emojis mean. Some of my favorites are like when people are tired of typing things out, they use the ship emoji to say, hey, you should ship this. Sometimes I've also seen people use the squirrel emoji for this. Oh wait, can I not spell squirrel? Maybe not. Ship it? No, never mind. That's a custom emoji that I have in a different repo. Never mind. But people just have conventions for these things. Now, why did this cause a problem? It caused a problem because my feature branch that I've just pushed is in conflict with master. And so I'm not able to just cleanly merge them in because there's a conflict. Now, one way to resolve this is I could do it locally. So I could try to update my branch locally, my feature branch, to have kind of the resolved version of what's on master right now, or origin master. But you can also do this through the UI. So I'm going to say resolve conflicts. And it's going to kind of show me essentially the same view that we saw locally, but a kind of nicer, prettier view of this. So it's saying, hey, these are our changes. We added X, and what's in master right now is this Y. You can choose if you want one or the other, or you can use this edit inline to kind of get the same thing as before if you want to keep both. Maybe just to make this a little bit clearer, there's no need that you have to have them on separate lines. Maybe I want to combine them onto one line, so I'll just say XY. And this is showing you what the commit is going to be, merging master into feature. Maybe to make this a little bit clearer to line up with the picture I'm going to show you, I'm going to call this M1. This is the merge one, and it's showing me a comment here. Like, this is the thing that changed. So commit this. And now it's saying all merge conflicts are resolved. You can see now that I have, if I refresh the page, there's actually 2 commits. This X commit is before, and this M1 commit. You can see all the changes here. It's really proposing delete the delete the Y line and add an XY line. That's how the change that we want to happen on master. And now you can go ahead and merge. So if I press merge, this is going to take this branch on GitLab and merge it into GitLab's master. So if I go back to my ABC repo, you can see that my file.txt now has this ABCDXY. Now, if you go look at the commits here, notice that there's actually 2 merge commits. I guess I should have changed this one when I went ahead and merged it. M1 was the merging of GitLab's master into GitLab's feature. But then what I really wanted was to get feature into master. Remember, I did that first merge to resolve the merge conflict on that branch. And then now I can merge from feature into master. This, I think, will be a little bit clearer if you think about kind of a pictorial view of what everything we just did. So we started with my local and remote repo kind of up to date. That last thing was that merge conflict that we resolved from the last video. Then I added a feature branch with commit X. Then Shadowhunter added a commit to origin master that was Y. Then we pushed our feature branch to master, and there was no error. There's no merge conflict yet. We just created a new branch on the remote. Then on GitLab, we saw that there's a merge conflict in our merge request. So we merged master into our feature branch to resolve this, and that was at M1. But now I wanted this change from feature into master, so then the actual pressing the merge button merged those together. Oh my goodness, such a complex process. But the nice thing that came from this was we were very intentional about all the changes that ended up in master. Obviously, this change was very contrived with just X's and Y's and all these little things, but I could always review kind of what it would look like before I actually send that stuff into master. So I'm very, very confident with the things that are going into master. Now, I want to mention a couple miscellaneous things about all of this. If I go back onto master on my local computer, you could see here that if I ran a git fetch, it says I'm behind master by some commits. The reason is because we just added a lot of commits there. If I go ahead and pull, kind of get all the changes from origin master, and I do this git log, you could see the same view that we had before. We have this merge feature into master. We also had that M1 commit that was merging master into feature to resolve the merge conflict. And notice all of that same stuff about like adding extra lines afterwards was there. It gives us extra context, which can be really helpful. Now, let me actually show you this git log --graph --one line. This is actually kind of starting to show the power of this view. It actually shows you a pictorial view of kind of everything that's happened so far. So remember, everything before the M commit right here is kind of everything that was happening in the earlier videos. So what did we do here? Well, we added a feature branch with commit X. And in the meantime, Shadowhunter added that commit Y to the master branch. And then when we pushed this feature branch, we wanted to make a merge request, but we had a conflict. The first thing we had to do was merge master into feature. So we could kind of get like what should, like assuming in some sense, I started this feature branch after Shadowhunter added that Y commit. So what would this look like then? And then I merged that into master to get the change in. So you could get some really complex graphs here, but it's a really nice view to kind of understand what was going on. Now, one thing you might be wondering was, can I delete the feature branch now? Yeah, in some sense, you might not need this feature branch anymore. It turns out the way I set up this pull request or this merge request is I actually had a button checked that you didn't see there that said delete this branch on master. If I want to delete it locally, you could use git branch -d that tells you to delete a branch. So I just deleted the feature branch locally because I don't need it anymore. You don't need to do this, but every once in a while, it's kind of nice to delete these branches that don't really matter. The other thing you might be wondering is, okay, so I might be getting this process a little bit, but isn't this going to always cause problem? There's always going to be merge conflicts, especially if I'm working with a lot of people. And it's definitely possible, and this is why it's nice to use this UI to kind of make sure you're really certain about the changes you're adding to master before you add them. But it's generally actually kind of rare to run into these a lot. The reason is, usually people are working on different parts of the project. In this ABC project, there's only one file, so we're getting conflicts all the time because Shadowhunter and I keep writing over each other. But in reality, if you're working on a big software project, there are lots and lots of files, and it's usually the case that you're not editing the same places all the time. And it's only going to have conflicts if you're editing the same file at the same lines of the same file. Otherwise, Git just is happy to merge these changes kind of automatically because there's no conflict, which is great. There are other ways of kind of getting a little bit fancier about incorporating changes. Primarily, there's this kind of other command called git rebase. It's a little bit complex, so I'm not going to show it to you, but you might see that if you kind of look out into guides out there. You might see this other command called git rebase, which is kind of useful, but starts getting into this kind of territory that I warned you about in the class session last time about rewriting history, which is usually not a good thing. Your next homework assignment, just because I noticed these videos are getting a little long, but I want to make sure we go through this kind of slowly, make sure we understood all the steps. Your next homework assignment is basically two parts. You're kind of going to do this first part where you kind of commit to a repo and push to master directly, and you're going to go through this pull request process. Now, one of the things that's going to make this assignment a little bit more complex is all of you, everyone in the class, is going to be working on our Fang repository. Everyone's working on the repo together, and so you might get merge conflicts, and that's okay. Part of this assignment is practicing how to handle merge conflicts. So you're going to get to work on, in somewhat an extreme case, where we have everyone in this class kind of working on the same set of files, but it's going to definitely be doable. You shouldn't run into too many merge conflicts, but you'll get practice resolving them. The last thing I'm going to mention, all of this Git branching and Git merging and this kind of rebase thing I just mentioned that I'm not showing you are all really interesting. One of the links I'm going to put on the website for today's lecture is a link to a game that actually teaches you, in some sense, how to do all this Git branching stuff in a gamified way. So usually are a set of puzzles where like, here's the set of the repo that's currently here. Here's the state of the repo I want to be at. Type in like 3 commands to get that. So that could be really good practice in honing this mental model of branches and commits. I encourage you to try out if you want to, but it's not required. It's just a fun resource. So hopefully you enjoyed kind of seeing all this Git stuff. Hopefully you can see how you can apply it to your projects, and especially partner projects or working on a team. And I hope you enjoy this next assignment.